I'm Justin Bushko from Concise Engineering. In medical device development, if a user can make a mistake that harms a patient, that is not a user failure, it is a design failure. Human factors engineering is not a test you take at the end of the project. It is a continuous discipline that shapes requirements, architecture, interface design, labeling, and ultimately the safety profile of the device. IEC 62366 makes that expectation clear. You must design out use errors, not just document them. Usability begins with observing real clinical workflows under real pressure, not calm lab environments, but operating rooms with alarms sounding, limited visibility, protective gloves, reducing dexterity, fatigue setting in after long shifts, and frequent interruptions that cause task switching. These environments expose risks that controlled studies never reveal. How do users respond when the screen is partially obscured? When the device is wet? When gloves reduce tactile feel? When multiple steps compete for attention? When cognitive load spikes during critical actions? Clinical reality identifies use errors long before they show up in incident reports. Those observations must translate into design improvements, clear displays with hierarchy that matches clinical priorities, tactile feedback that confirms activation without requiring visual focus, button spacing that prevents accidental presses, connectors keyed to prevent misalignment, workflow simplification that reduces the number of steps or decision points, alarm messages that are unambiguous and actionable, physical design features that prevent incorrect orientation or unintended actions. Every improvement reduces use-related risk and strengthens your risk controls under ISO 14971. Formative studies refine these ideas as the design evolves, testing early prototypes with actual users and capturing misunderstandings, hesitation, or unintended behavior. Summative usability testing then proves that the final production intent design supports correct use and mitigates hazards even under stress, distraction, and worst-case conditions. Regulators expect objective evidence that real users, not engineers, can operate the device safely. Good usability reduces risk, accelerates training, improves adoption, reduces complaints, and strengthens regulatory submissions. It also builds confidence with clinicians who expect devices to support them, not challenge them. At Concise Engineering, we embed human factors throughout development, aligning usability with clinical reality, risk management, and design controls. When a device feels intuitive from day one, everything else, safety, compliance, and market acceptance, becomes easier. Let's design devices that support users, prevent harm, and perform reliably in the environments where lives are on the line.